The past 2 decades of technological advances in robotics, drone technology, and autonomous vehicles all have one thing in common. They depend on allowing machines to see the world in 3 dimensions. 3D vision systems use a variety of approaches for determining depth, including LiDAR sensors and stereo cameras. One of the more flexible and easy-to-deploy technologies that has emerged is time-of-flight, or ToF. ToF cameras work by scanning the scene with pulses of invisible infrared laser light and then observing the light that is reflected by objects in the scene. Since we know the speed of light, we can calculate the distance to each point based on the time it takes for a pulse of light to travel from the emitter to an object in the scene and then back again. Indirect Time-of-Flight, or iToF cameras, use diffuse infrared laser light to illuminate the entire scene. The light is continuously modulated by pulsing the laser at a known frequency. Rather than directly measuring the interval between each pulse of light and the time when it is reflected back to the camera, iToF cameras record the reflected waveform in each pixel of the sensor. A simple computation allows the system to determine the distance to the corresponding point in the scene based on how much the waveform is phase shifted in each pixel. The more out of phase the waveform is, the further away the corresponding point is. Indirect ToF sensing technology makes it possible to determine the distance to all points in the scene in a single exposure. The result is a depth map, where each pixel in the image encodes the distance to the corresponding point in the scene. The depth map can be viewed as a false color video, where points that are most distant from the camera are blue, while the points closest to the camera are red. The data from the ToF sensor can also be processed to create a streaming point cloud that allows the scene to be viewed and manipulated in 3 dimensions at up to 60 frames per second. Because of their ability to provide real-time depth information, time-of-flight cameras are used in a wide variety of applications, including industrial automation and robotics, where they provide object recognition capabilities to robots and even allow them to navigate and avoid collisions. ToF cameras are also used for logistics applications, like sorting, measuring, and stacking packages. ToF cameras are used inside autonomous vehicles for applications like gesture recognition and attention tracking. Time-of-flight cameras are even finding their way into retail stores, where they are used for people counting and tracking shoppers as they move through the retail space. To help support vision system engineers who are developing new applications based on this technology, we've created a ToF development kit. The development kit includes a fully calibrated camera module based on Sony's latest generation of indirect time-of-flight sensors. The development kit is designed to interface with NVIDIA Jetson's system-on-module embedded computers, so engineers can quickly develop and deploy a compact working prototype system based on widely used technology. To help you meet specific operating requirements, our engineers can work with you to configure your development kit and help you accelerate the creation of exciting new applications based on this breakthrough technology. To learn more about time-of-flight technology, visit the FRAMOS.com website.